Enterprise architecture becomes real when strategy turns into governed change. In this module, the TOGAF ADM provides the engine, an iterative path from vision and requirements through design, migration, implementation, and continuous improvement, applied to our Azure AI platform case study. Before we dive into the ADM, let's anchor where we are. You've already covered enterprise architecture value, TOGAF fundamentals, principles, requirements, stakeholders, and the Azure Secure AI case study. Now we move from concepts to a repeatable method for guiding real architecture change. The ADM is the engine of TOGAF. It brings business strategy, information systems, technology, security, and governance into one managed architecture journey. Architects begin with a vision, develop business, data, application, and technology architectures, then shape opportunities, migration plans, and implementation governance. The important point is that this is not a one-pass waterfall. Requirements, stakeholder concerns, principles, and decisions continue to flow through the method. That gives the work traceability, so deliverables and roadmaps can be linked back to the outcomes the enterprise needs. Think of the ADM as a life cycle for turning architecture capability into real change. First, the organization sets the rules, principles, governance, methods, and tailoring. Phases A through D define the target architecture: vision, business, information systems, and technology. Phases E through G turn that target into action through solution selection, migration planning, and implementation governance. Phase H keeps the architecture current as needs change. At the center is requirements management, because requirements are refined, checked, and controlled throughout every phase. Architecture work begins by setting direction before designing solutions. The preliminary phase builds the capability to do architecture well: principles, governance, roles, tools, and readiness. Phase A then turns business drivers and stakeholder concerns into a clear architecture vision. It defines scope, constraints, target outcomes, and how value will be judged. In the Azure AI case, this means agreeing why the platform is needed, who it serves, and what success looks like. These early decisions keep the effort anchored to business priorities, not just technology choices. With the vision agreed, TOGAF moves into the three core target architectures. Phase B defines what the business must be able to do: capabilities, processes, value streams, organization changes, and outcomes. Phase C translates that into information systems, separating the data the enterprise needs from the applications that create and use it. Phase D defines the technology foundation: cloud, infrastructure, networks, security, platforms, and runtime environments. Across all three phases, architects compare baseline to target, identify gaps, and build the evidence needed for solution planning. Once the target architecture is defined, the ADM shifts from design into action. Phase E explores practical options, including solution building blocks, transition architectures, and implementation approaches. Phase F turns those options into a migration plan, sequencing increments, dependencies, costs, and investment choices. Phase G provides governance during delivery, checking that projects stay aligned with the approved architecture. Phase H keeps the architecture alive after implementation by watching for business, technology, or regulatory change, then feeding needed updates back into the ADM cycle. Requirements management is the control loop that keeps the ADM honest. As architecture work moves from vision to design, planning, implementation, and transition, requirements are not collected once and filed away. They are refined, prioritized, validated, and traced as decisions become more concrete. This is especially important for AI systems, where new needs can appear late. Privacy constraints, explainability expectations, model performance targets, integration limits, or regulatory obligations. Good requirements management prevents uncontrolled scope drift while still allowing disciplined adaptation when stakeholders, risks, or evidence change. A useful way to view the ADM is less like a straight road and more like navigation with checkpoints. You set a direction, test it against what you discover, and recalculate when conditions change. A stakeholder concern may send you back to refine requirements. A feasibility issue may change the architecture. Implementation may reveal constraints that require another pass. That is not failure. It is how architecture becomes realistic. The key is controlled iteration. Use governance, capture decisions, and manage requirements carefully. So each loop improves quality rather than creating churn. ADM iteration is not one generic loop. It can focus on different concerns. Capability iteration improves how the organization does architecture, including governance, standards, roles, and methods. Development iteration refines the architecture itself, moving between baseline, target, gaps, and definitions as understanding improves. Transition planning iteration works out how change will be delivered, adjusting roadmaps, dependencies, work packages, and sequencing. Governance iteration closes the feedback loop during implementation, using compliance reviews and delivery evidence to refine decisions. The key is to iterate where uncertainty or learning is greatest. Tailoring the ADM means making the method useful, not making it optional. Every enterprise has a different risk profile, pace, maturity, and delivery model. A regulated bank may need formal evidence, review boards, and detailed artifacts. A digital product team may need shorter cycles, lighter documentation, and tighter links to agile delivery. The tailoring decision asks which phases, checkpoints, deliverables, and governance controls are necessary to protect outcomes without slowing progress. The principle is simple: tailor the method, not the accountability. Architecture discipline remains. Unnecessary process overhead is removed. Tailoring also means choosing the right cadence, artifacts, and controls for the type of work. In agile delivery, architecture must move in shorter cycles, shape the backlog, and provide runway without slowing teams down. In cloud programs, ADM outputs need to connect to landing zones, shared services, identity, network, policy, and cost decisions. For AI, the method must include data governance, model lifecycle, responsible AI, monitoring, and human oversight. Across all of this, governance keeps decisions traceable to implemented controls and real operational evidence. Architecture work needs a controlled path from demand to reusable outcomes. It often starts with an architecture work request, which captures the business need, drivers, scope, and expected results. That request is then shaped into a statement of architecture work, where stakeholders agree on the approach, constraints, resources, and deliverables. From there, the team produces formal deliverables, such as vision documents or architecture definitions, for review and approval. The detailed artifacts behind those deliverables become practical design views and may mature into architecture or solution building blocks that future initiatives can reuse. In our case study, the ADM turns a secure Azure AI platform from a technology project into governed enterprise change. It starts with business demand, then shapes the target architecture, migration roadmap, and implementation governance. Tailoring matters because cloud foundations, data governance, model lifecycle, identity, security, monitoring, and compliance all intersect. Work packages become practical. Landing zone readiness, data platform design, deployment patterns, access controls, and operating metrics. Iteration is expected. Responsible AI, regulation, data quality, performance, and cost will change. So architecture governance must keep decisions traceable, adaptable, and aligned to outcomes. The key takeaway is that the ADM is not just a sequence of phases. It is a disciplined way to organize change, supported by iteration, tailoring, governance, and traceable work products. You have seen the life cycle and the main outputs that make it practical. Next, we move from understanding the method to establishing the capability to use it well.